Hello everyone, today we're going to go over the element hydrogen. Hydrogen is element number 1 on the periodic table. It is the lightest, the least dense, it is colorless, it is odorless, and it is diatomic, which means that it sticks to itself in order to remain stable. Today we're going to go over its history, its uses today, how it was made back then, how it's made today, and how we find it in today's world and in all the various compounds and forms, whether pure or not, such as these hydrocarbon oils, this hydrochloric acid, this molecule of water, this molecule of hydrocarbon, and this individual right here. Let's begin. In 1776, a young individual known as Henry Cavendish endeavored on isolating hydrogen from its pre-existing bonds because hydrogen exists in nature in many forms, in many molecules, and many bonds. Here are just a few examples of how hydrogen is bonded to other elements. Here's hydrochloric acid, an element or a molecule involved in the separation of hydrogen in the original experiment that Henry Cavendish produced. And here are other examples, if we zoom in, of other molecular bonds that hydrogen creates with other elements, in this case carbon. Methane, CH4, which is just a combination of one carbon bound to 4 other hydrogen atoms. Ethane, which is just 2 atoms of carbon bound to 1, 2, 3, 4, 5, 6 atoms of hydrogen. And propane, which is just, as the formula states here, 3 atoms of carbon bound to 1, 2, 3, 4, 5, 6, 7, 8 atoms of hydrogen. So hydrogen exists in many bonds in the natural world. Henry Cavendish was one of the first people to endeavor and isolate hydrogen from its pre-existing bond and get it as an individual element. We're about to see how exactly he did that. So let's zoom out over here and see the general overview of his works. Getting a bird's eye view of the whole history of hydrogen, we're about to endeavor on the journey that Henry Cavendish once endeavored on, which involved separating hydrogen from its chlorine bond using zinc metal to create zinc chloride and hydrogen. What Henry Cavendish did was take a piece of zinc metal and combine it with liquid hydrochloric acid. Hydrochloric acid is a fusion of hydrogen and chlorine. Here's an image of the molecule. In this solution right here, there are millions and millions, maybe even billions of molecules that look exactly like this, which have one hydrogen bound to one atom of chlorine. So each of these combined create this whole liquid. And when you combine these molecules with this zinc metal, you start to get a reaction because metals tend to lose their electrons very easily. And hydrochloric acid, the definition of an acid is that it dissociates in a liquid, such as H2O. Dissociation just means that when it's in liquid form, the hydrogen atom will separate from the chlorine atom and they will be separate while they are in liquid state. All this means is that the hydrogen will be H plus in solution and the chlorine will be Cl negative in solution. And all of this is taking place in this solution right here. And as a result of the separation of the molecules in the atoms, the zinc separates along with the separated hydrogen atoms and the chlorine atoms. Since the hydrogen is already separated from the chlorine, the zinc jumps in, it donates its electrons, it becomes a faster element in solution, and it starts separating and recombining. The process of separation allows for new combinations of elements to be formed in the process. The result of all of this is new molecules and new atoms that form that allowed Henry Cavendish to be able to classify hydrogen as a new element. So here we go. The products of these molecular recombinations are zinc chloride, which is just a fusion of zinc and chlorine. As you can see, the chlorine was separated and the zinc separated, so it recombined. The chlorine that was separated in the solution recombined with the zinc metal, and the hydrogen, since it was separated already by itself, it had nothing else to do but recombine with itself again. Since hydrogen again is a diatomic molecule, it recombines as H2. So H2 will just recombine, the H will find another H, and since the zinc donates a lot of electrons in the solution, the hydrogen finds some electrons to bind to, and as a result it's able to stabilize and become a hydrogen atom that's neutral, and then it combines with itself and then it becomes hydrogen H2. Here below we see a visual demonstration of how that separation might have looked like in his laboratory. We see a delivery tube along with hydrogen gas bubbles being created from the separation with the acid itself. Here you can see that the acid is not hydrochloric acid. Usually hydrochloric acid is hydrogen combined with a chlorine atom, but sulfuric acid is a different type of acid in which it is a combination of 2 atoms of hydrogen combined with 1 atom of sulfur and 4 atoms of oxygen. The oxygen makes it way more reactive, but again the hydrogen is still involved in the acid. In fact, acids are a big component of hydrogen. So we're learning about hydrogen element. Hydrogen is very important in the creation of acids. Since hydrogen separates so easily, since it's just a proton from its original bonds, it can create acids because it separates so easily in solution, just like we saw here with the hydrochloric acid separating and binding with the zinc and recombining to form zinc chloride. So right here, the sulfuric acid is used to create the hydrogen gas, and then the hydrogen gas goes through this delivery tube, and the hydrogen gas starts combining with itself as a diatomic molecule. As we can see here, the end product of the combinations of the acids in the metal is a diatomic molecule of hydrogen, H2, because H by itself is just one proton and one electron, and the innermost electron shell, the first shell of the electrons, let's draw one. This is a proton. The first shell wants to have 2 electrons in its outermost valence electron shell. Apart from that, it's 8. But the original orbiting electrons, it wants 2 of them. But since hydrogen comes packed with just 1, it needs 2 hydrogens in order to combine with itself. So here I'm going to draw another hydrogen atom very quickly. And here's another one. And here is the fusion. Now, when these two H2 atoms are combined, which is 2 atoms of hydrogen, they each share an electron and are stable. They have the 2 electrons that they wanted from each other, and now they are sharing the electrons, and now they are stuck together. And that's why the end product of this formula is H2, and that's why these bubbles are forming as the H2 is fusing together with itself. H2, H2, H2 is going up into the air, and H2 reacts with the oxygen in the air. So as you can see here, the burning of hydrogen gas with a pop sound. Somebody is testing for hydrogen gas formation by burning it with a candle and combining the hydrogen with the air back. So what happens in this reaction is that the hydrogen combines with the oxygen in the air and creates H2O, the famous water molecule. So when hydrogen burns, it creates water. That's an easy way to remember it. H2O, H2, hydrogen bonds to itself, is just attached to an extra oxygen from the atmosphere. When hydrogen combines with the oxygen from the atmosphere, it forms a drinkable water that we know and love every day. The word hydrogen means, in Greek, water forming, because in exact proportions of 2 atoms of hydrogen and 1 atom of oxygen, you get what we know as a water molecule. And a water molecule is essential for all life on Earth and in the universe, if there is life as we know it in other planets in the universe. We consist of 10% hydrogen and 65% oxygen. When those 2 proportions of atoms meet, we get what we know as water within our bodies. We are made of a lot of water because water is essential for conducting a lot of chemical reactions that are essential for life as we know it. Without those chemical reactions occurring in our bodies, we wouldn't be able to form the amino acids, other proteins, and other chemicals that we need in order to be alive. Our brain would not be able to sustain itself. Our brain creates electricity and floats in a fluid of water called cerebral fluid, and that's what it floats within, and that's also consistent of water. We think using water. When we run out of water, we start to only think about water. When are we going to get our next drink of water? We get thirsty way more quickly than we get hungry, because water is way more essential of a mineral than food is to our bodies. Again, the word hydrogen means water forming. So water is important in our bodies and in the universe, and it so happens that the first element on the periodic table is named after a very important molecule in the universe. Here we have an array of 3 different types of molecules which consist of 2 different types of atoms, carbon and hydrogen. We'll soon talk about the element carbon in another video. Today we're talking about the element hydrogen, but it's still relevant for both. So what is a hydrocarbon? A hydrocarbon is a compound containing only hydrogen and carbon as an atom within the molecule itself. So here we have methane, which is CH4. Here we have ethane, which is C2H6, and here we have ethane, which is C2H4. And there's different types of molecules because there's different types of molecular organizations and different types of molecular numbers within each molecule itself. So here we can zoom out and see all the various types of things that hydrogen is involved in. Hydrogen is element number 1 on the periodic table. Hydrogen is a gas. Hydrogen again is used as a hydrocompound, so it's a hydrocarbon which is used in gasoline. Gasoline is an octane, and the molecular formula for that is C8H18, which means that there are 8 carbon atoms and 18 hydrogen atoms within the molecule itself, and that's what gasoline is. So every time you fill up your car with gasoline, you're putting in a bunch of molecules which consist of 8 atoms of carbon each, along with 18 atoms of hydrogen. So that's what gasoline is. You're basically adding carbon and hydrogen to your car in order to burn it and combine it with the air around it and allow your car to release energy for motion. We talked about acetylene in the neon video because it was involved in welding, and welding is a process that involves involves neon, but it also involves the element hydrogen, because hydrogen is a molecular compound that we discussed. It's a hydrocarbon combined with hydrogen and carbon. As we can see here, acetylene is only a measly 2 atoms of hydrogen combined with 2 atoms of carbon. It's almost as light as water itself, which makes sense as to why it's so reactive and why it heats up to such high speeds and high velocities, because it's a light molecule, so it can accelerate to high velocities and therefore release a lot of energy and heat that is therefore used for welding and fusing other metals together in the environment. So here we have other processes that hydrogen is used for. Here is just a diagram that shows the petroleum products made from a barrel of crude oil in 2019. Used for other products 6.0, jet fuel 4.4, distillate 12.5, and gasoline 19.4. So the majority of what a petroleum barrel is used for is gasoline, and the rest is used for other products. Jet fuel is basically gasoline for jet engines, but it's not considered a gasoline because it's a different type of molecule that's used to run the jets. Following that, we see NH3. NH3 is ammonia consisting of 3 atoms of hydrogen and 1 atom of nitrogen. Nitrogen will soon, as we will find out in the nitrogen video, is a very important element for soil and planting because it has a lot of energy. Hydrogen and nitrogen combine together to release a lot of potential energy because the nitrogen is not stable in this way. It wants to recombine with other nitrogen atoms, or it wants to get an electron, or it wants to get something else to stabilize itself. The strongest bond actually in the nitrogen bond is the nitrogen bond. It has triple bonds, so it's super compact and super close together when it's bonded to itself. So it's super hard to separate nitrogen, which is why it releases a lot of energy when it's combined with other things, because as it recombines with itself into this nitrogen triple bond, it releases a lot of energy into the environment, which is why this is very important to keep in mind and be wary of. It's a very dangerous element potentially because it could be used for explosions and stuff. In fact, people have used these in the past for like compost and stuff. They've created artificial bonds with that. Do not use nitrogen for that purpose, as well as hydrogen. Hydrogen and nitrogen are meant to be used for things such as helping plants and food grow, and that's exactly what it's used for. Use the elements for a positive thing rather than a negative thing, because there are various things that you can do with the elements, but there are only a select number of things that you can do that affect humanity in a good way. So always focus on the good things that the elements can do rather than the bad things. So as we continue, we can see a fuel cell stack. Hydrogen is involved in the process of a fuel cell because fuel cells are used as an alternative. They're designed as an alternative source of energy to other things such as burning coal or burning carbon and burning hydrocarbons, because the byproduct of burning hydrogen is merely water. So here we go and explaining. This photo is not an animation, but the previous photo is like a GIF. It's an animation, so I'll explain what the GIF was basically saying. So the hydrogen fuel goes through here and it goes here. It goes through the anode because this is where the electrons originate from. The hydrogen H2 goes through here. It goes through this proton exchange membrane, which removes the electron from it and allows only the nucleus, because a hydrogen is just a proton. So the protons flow through here, similar to the way that we flow to in nature or in cells, and they flow through here, and only the electrons are allowed to flow through the cable, and they flow through the wire, and they power whatever is connected in between. That is the big component of the fuel cell stack. So as the protons go through here, they recombine with their electron, and they don't produce just hydrogen, they produce oxygen, because they combine with the oxygen in the air to produce water, and that is the result. As a result, all that is very energetic and it produces a lot of heat, so that heat is dissipated and the oxygen from the air enters here to combine with the hydrogen that's exiting here, which is just a proton when it's exiting, but it's recombining with its electron to allow it to finally become water. Air and water vapor is released, and nothing that can potentially pollute the environment is released, and therefore a safer and friendly environment is achieved. Hydrogen originated from space. It's one of those elements that exists literally everywhere, not just on planet Earth, but everywhere in space. In fact, most of what the universe is hydrogen, because everything that you see, everything that you can touch, everything that you can't touch or feel in the universe is made from hydrogen. Everything that you see is hydrogen fused together into more complex components and more denser energies, thanks to the help of fusion and thanks to the help of these massive stars that compress all of their internal energies together together and start fusing heavier and heavier elements within their cores. As you can see here, here's a diagram that shows just how the elements start to fuse. So you can see here hydrogen is at the outermost because it's the lightest, helium is the next heaviest, then carbon mixed with oxygen, then neon, then oxygen, then silicon and sulfur, and then finally iron. Iron starts absorbing energy instead of releasing it into the environment like a star, because a star's purpose mainly essentially is to release energy and glow, and all that fusion energy that it's releasing as a result of fusing the elements together is glowing. What you see as a glow is merely the energy being released from the elements fusing together into heavier, denser elements. What is lost from the elements as a result of fusing into heavier and heavier elements is a little bit of mass, and all that mass is released in the form of light, in the form of energy, in the form of heat. Just like a little bit of uranium releases a lot of energy in the form of an atomic bomb here on planet Earth. So here we can see a demonstration of all the stars in the sky. All of these stars in the sky that you can see in this image are producing new elements. They're fusing elements together from the original element, hydrogen. Hydrogen is important. If there's one thing you can remember about hydrogen, is that everything is hydrogen fused together into denser elements. Well, technically everything is helium, because as you can see here in this diagram, as I previously described in the helium video, that everything is just a fusion of helium. Once hydrogen fuses into a helium nucleus, which is just two protons and two neutrons. Proton is made into a neutron through positron emission decay. As you can see here, I took an article from the internet. It says radioactive decay through a loss of a positron. A proton is converted into a neutron and a positron. The product has one fewer proton in the nucleus and the same mass number. Helium-2 is converted to hydrogen-2. Let's try to visualize it. So let's say you have one proton and one electron. Now let's duplicate these. That's 1. That's 2. And now let's duplicate it again. That's 3. And now let's add another duplicate. So now here we have 4 hydrogen atoms. They don't have any neutrons, but they do have the components that are needed to create a helium atom. So what is a helium atom composed of? Helium atom has 1 neutron and 1 proton fused together with another neutron and another proton. Together, they have 2 electrons orbiting them. And that is a complete helium atom. So how do we get from all of these 4 hydrogen atoms into this? I don't even see any neutrons. How does a neutron even appear? Does it just come out of thin air? Well, technically it does, and it doesn't. We're going to explain it using some physics and some logical processes. As you can see here, hydrogen plus hydrogen plus hydrogen plus hydrogen equals helium plus energy. As I mentioned before, the energy is just the mass that was lost from the previous fusion, because every time atoms fuse together into newer, heavier elements, they release a lot of energy, and that's what we see as energy from the sun. We can even feel that energy if we go outside and try to reach out for the sun. We can feel its radiant heat because it's fusing all those elements together, and we can feel it from an average of 150, usually 93 million miles away from the sun. We can still feel that fusion energy because it's so intense and so immense, and a lot of elements are created every single second. In the case of our sun, not many elements are created, such as in this diagram, all the way to iron, but carbon is made as well as helium and hydrogen, and that's important because that's what produces the energy here on planet Earth for photosynthesis in all life. As we mentioned before, 4 hydrogen nuclei, 4 hydrogen equals 1 helium. Let's keep this here into focus, but let's redirect the attention to the proton. As mentioned before here in this article, a proton is converted into a neutron and a positron. That's all we need to know. So a proton is converted into a neutron and a positron, which means that it's turned into this. We're going to represent the positron with this. So this is a neutron and this is a positron, and this is the original proton. So this plus that is equal to the proton. So the neutron plus the positron is equal to the proton. So as you can see here, nothing is really lost. In fact, this makes sense because, as mentioned before, the energy that was lost, as it states here, 26.7 mega electron volts is released from the fusion of 1 hydrogen plus 1 hydrogen plus 1 hydrogen plus 1 hydrogen to make helium. So the energy released is actually not lost. It's accounted for in the form of the positron. Technically, we can say that the energy that we don't see but feel is the energy of the positrons being released out into the universe, out into the environment. What's being left is a neutron for the generation of helium. So eventually, when 2 neutrons are created, they can be combined with 2 protons. So 2 of these will be sacrificed to become neutrons, and 2 of these will be sacrificed to become or to remain protons. And together we get this result. Hydrogen is a very important component in the generation of new elements. Everything is created from hydrogen. Once you create helium, you can create all the other elements by just combining helium and another helium together, because helium already has the neutrons needed to make all the other elements that are included. Because once helium is created, you have the ingredients necessary to make all the other consecutive elements following that, because it has the protons within it that allow it to combine and form and fuse into those new elements. So bigger stars produce greater quantity of elements. As you can see here, this diagram doesn't produce that much because it doesn't have as much mass. Well, actually it's producing a similar amount of elements. Let's just draw them out. Bigger stars, smaller stars. Bigger stars will fuse a greater amount of elements than little stars. LS for little star. If you have a bigger star, it creates more elements for a shorter amount of time, because here's a fun fact. As elements start to fuse into heavier and heavier elements, they take less and less time to create the next element on, which I think has something to do with general relativity and Einstein's equations on gravity and stuff, but that's not exactly proven yet. So we're just going to leave with the fact that the heavier the element gets, the faster it fuses, and it takes less and less time to fuse into heavier and heavier elements from the previous element before it. In summation, without hydrogen, there is nothing. Because hydrogen is essential in creating helium. From 4 protons, 2 of them become neutrons and 2 of them remain protons. They fuse together, they keep their electrons, and they become the product of a helium atom. And that helium atom is essential in producing all of these other elements consecutively. If you have 2 helium atoms and you fuse them into 3, you get carbon. If you have 3 helium atoms and you fuse them into 4, you get oxygen. If you have 4 helium atoms and you fuse them into 5, you get neon. If you have 5 helium atoms and you fuse them into 6, you get magnesium, and so on and so forth until you get all of the elements on the periodic table. So that concludes the video on hydrogen explained in 22 minutes or less. The previous video was on oxygen explained in under 20 minutes or less. If you want to watch that video, the link is in the description below. There's so much to talk about hydrogen that we can't compress it in one video. I just try to get the general information out. We'll make a part 2 in the future. We'll continue to mention hydrogen in all the other videos that are upcoming, because hydrogen is involved in various other compounds and combinations and chemical reactions and other molecules. So this is not the end of hydrogen. This is just the beginning. Thank you guys for watching.